Hello friends, welcome to DHIKSOOCHI. This is the fourth part in investment decisions. In earlier videos, we discussed average rate of return, payback method, and net present value. In this video, we see internal rate of return, that is IRR. If you revise evaluation techniques, we discussed that there are two different techniques. One is traditional techniques and the other one is discounted cash flow techniques. Traditional techniques cover average rate of return, payback method. Discounted cash flow techniques cover net present value, internal rate of return, and profitability index. So, we are studying internal rate of return in this video. Why all we are using these techniques? Do you remember what was our discussion in the first video? If not, let me tell you. So, if an investor would like to invest in a company, he may be having several alternatives like project A, project B, project C, project D. Let us assume probably all the four requires the equal investment, but he cannot invest in all the assets, right? In that situation, he has to decide which asset is working well for him. For that, he apply all these evaluation techniques, then finally come to a conclusion that either A, B, or C, or D probably may work good for him. Then he is going to investing in that selected project. That is what the evaluation techniques help us to decide which project is working well for us. So let us start with internal rate of return. This is actually a discount rate. What is this discount rate? Where it equates the present value of cash inflows with the initial investment. Okay, so both are equal. See, if you recollect NPV formula, in NPV we studied that summation T over 1 to NCFAT divided by 1 plus k whole power t. If there are any salvage value and working capital, these are also will be discounted at the same rate in the fifth no nth year. But here we had minus C naught. In IRR we are having equals to. In which rate, that is this k, when it equals the present value of cash inflows equal to present value of cash outflows. So the rate at which the present value of cash inflows are equal to present value of cash outflows, that we call it as the rate is called it as IRR. Clear? So of course, if you see the accept reject criteria, if you want to select the project, then your IRR should exceed the cutoff rate. What is this cutoff rate? See, for example, here we have assumed that R as small r, IRR as small r, cutoff rate is K. So, what is this cutoff rate? Cutoff rate in the sense predetermined rate this is at which you want to get the profit. So, there's a predetermined rate. So, if your return is more than the predetermined rate, your discount rate is higher than the predetermined rate, then you are going to accept the project, and vice versa. If R is less than K, then you are going to reject the project. Clear? Now, this is a general introduction of IRR. Now, if you see this computation, it is totally like an NPV method. We can say it is actually an extension of NPV method. We apply 2 to 2 or 3. We can say 2 or 3 NPVs. We calculate 2 or 3 NPVs to approach a particular IRR. It is not enough these 2 to 3 NPVs. Further, we have several formulae. You can apply either of the formulae to get what exactly your K is or R is. So whatever either K or R, this is your IRR. Okay, this is what actually the procedure. So of course this procedure is little tedious, but if you know NPV and you can remember the formula, then this IRR method is also very easy. Clear? So here I have mentioned the steps for annuity. So there are two methods we apply for IRR. One, when the cash flows are when the cash flows are equal throughout the year, throughout the project duration. Okay, so when these are same every year, you are getting expecting the same return, then we call it as an annuity. Okay, so here we have one kind of a procedure. The other way, when the cash inflows are uneven, when the cash inflows are uneven, then we are going to apply NPV method. So we apply 1, 2 like this NPVs, and you try to find out that at which the discount rate in between these two is your K approach to. Clear? Now, let us start with annuity. Let us see the formula IRR, then we set R. What is this R? This is a discount factor, discount factor for interest rate R, in the sense at which rate you are able to calculate that NPV. Okay, so here I mentioned that. Then we have DFRL. Okay, L means lower interest rate and H means higher interest rate. So this is common for either higher interest rate you take it here or lower interest rate you take it here. This DFRL and DFRH is same for the calculation. Now, if you come for the numerator, there you can see PB. This is a payback period. In the sense, the annuity factor requires the payback period if at all you want to calculate. Then DFR. See here, there is no H, there is no L in it. Means you are taking discount factor at the rate R. What is this R? This. This can be, again I told you, I'm telling you, either it is a rate at higher rate or the lower rate of higher rate, as well as you're also considering the discount rate of the lower rate. So this is how you apply. This is generally for annuity factor you apply. Okay, for annuity method. Whereas this formula, when you calculate using NPV, when do you use NPV for IRR? When the cash flows are unequal. Then you apply this formula after getting two different NPVs at two different discount rates. Same way again you have there higher interest rate and lower interest rate. Okay, so by multiplying this higher interest rate with present value and lower interest rate with present value, then you are taking those differences same as this above formula, but here we are considering the present value of cash outflows. Now let me explain you the procedure. First, let us check with this procedure with a simple example at annuity. Means it has equal cash inflow. Okay, equal cash inflow. Fine. Now, so here is a question example they gave. Project cost is 36,000. What do you mean by project cost? That is investment. So your investment requires 36,000 to start a business, which is you have an option. Then it is also giving you some data, that is you are expecting that you are going to generate cash flows every year. Cash flows every year is 11,200 rupees. Got it? So if you are selecting a project, in the sense that investment required 36,000, and you know that it is giving you 11, it is going to give you 11,200 rupees every year, and the project duration is 5 years, means all 5 years your expected cash inflows are 11,200. Now we need to calculate the IRR of this project. Clear? So we are not having any cutoff rate here as of now. We are just checking with the process of IRR. Okay. So if you want to know the cutoff rate, let us assume 12%. So if you consider accept reject criteria, then when to accept this IRR? If IRR is greater than 12%, you accept it. If IRR is less than 12%, reject it. Clear? Now let us see how we can apply this formula. So as you remember, we need to calculate the payback method, right? So given the project cost is 36,000, annual cash inflow is 11,200, duration is 5 years. Yes. Now what you need to do? We have to calculate the payback period. What is the payback period here? Do you remember the second video what we discussed? That is the total project cost or the initial investment. I'll write here. Okay. So project cost or capital or investment or investment divided by the average cash inflow. Average cash inflow. Average cash inflow means every year it is generating 11,200 for 5 years now. So obviously the average cash inflow will become the 11,200. So what is your project cost? 36,000 divided by your average cash inflow is 11,200. So your value is 3.214. First step is done. That is the payback period of this project is 3.214. Now how to proceed further? Fine. If you see here, there are two tables. This is A3. The above one is an A3 and this is A4. So we have we need four informations here. One is, first we know that 5 years, our duration is 5 years. So here we have the 5 year, right? Fifth year, against fifth year, we should look for 3.214. What is 3.214? Our payback period. So if you go across these 5 to the respective values, then where we can see 3.214, you need to find out. See here we have 3.274 at 16% and 3.199 at 17%. So at 16%, 3.274, at 17%, 3.199. Of course, we don't have the exact value of 3.214, but we have the nearest value. Those are, one is higher, the other one is lower. Higher value at lower discount rate, lower value at higher discount rate. Now, how we are going to use them? As per our table A4, we found two different values. One is at 16%, one is at 17%. 16% the value is 2.274 and 17% the value is 3.199. So if you see the D 16%, this is 17%. Which is the highest one? This is the highest one. This will be your DF highest R. Okay. DFHR, that is 3.199. Clear? Then 3.274 will be your DFHL, sorry, LR, lower rate, right? Now this is your R. This is also R, but you can use only one R, either 16 or 17. Now let us substitute these four values also the PB value in the given formula and find out IRR. This is your IRR formula. You know R. See, for example, if you want to consider 16%, then your R will be 16. If you want to take R as 17, you can take 17 also. Then your DFR is going to be changed. So, if you take R as 16%, your DFR will be the discount factor at 16%. That was 2.274, right? You know PB, you are taking PB as 3.214. Now, see here DFRL and DFRH. So, this is DFRL, right? So, this is DFRL, that is 3.274. At 17%, this is the highest interest rate now. At this, the DFR was 3.199. So, you are taking 3.199. After substituting all these values, you are going to get 16.8. As of now, the 16 point, your IRR is greater than your cutoff rate of 12%, right? You're going to accept the project. Fine. Let us see the same formula using 17%. Okay. If you use 17%, your PB will be same. But what happened to your DFR? That is discount rate at 17%. That is 3.199. And the remaining DFRL, DFRH are same. Now let us see the solution now. See here R17, PB payback period 3.214 same, DFR 3.199, this was at 17%, right? Then the denominator is same. If you substitute that, then you get the same value. It means you can use either lowest interest rate or the highest interest rate. You are going to get the same answers, right? So if you are supposed to calculate IRR, then either you can use this method, means that lower interest rate, or higher interest rate. Now let us see this formula for mixed stream of CFAT. This method we call it as trial and error method, because we trial the R. Sometime, let us assume, sometime we take 10%, if not satisfied, again 12%, or 15%, or 20%. Like this, we trial to calculate NPV till we get one negative NPV and other positive NPV. Till then, we were going on substituting these percentages, discount rates. Then we approach to minus NPV and plus NPV. So at whatever the rates you have taken these two, in between we are going to get our IRR. So first method is we need to calculate NPV, right? Okay. So these are the cash inflows, sorry, duration of the project. Machine A, these are the cash inflows. Machine B, these are the cash outflows. If you observe, the investment is same for both the projects. Okay, so we are going to apply NPV. NPV was discussed in the third video on investment decisions. If not watched, please watch that video and come back here. Then only you will be able to understand very quickly and easily. Now, let us get into the process. Let us assume the NPV discount factor is 18%. Then, what are those values? You know how to check it in the table value, right? If you don't know how to check it in the value, I'm planning to record one more video on how to check the present values and also annuity factors. Then you can watch that, can understand. Now, let us calculate the NPV at the 18% for machine A. So, how you calculate it? Your cash flows will be taken and PV factor at 18% will be taken 0.847, 0.78, 0.609, 0.516, 0.437. So at present, let me show you where we are getting all these values. This is table 3. Table 3, you are calculating for 18%, right? So if you see here 18%, you have to take all the 5 years, 0.847, 0.718, 0.609, 0.516 and 0.437. These are the values you need to take it. So we have taken the same values, right? 0.847, 0.719, 0.609, 0.516 and 0.437. Now, what you do? We have to calculate the PV values, that is PVs, present values. How do you get them? Multiply 14,000 into 0.84, multiply CFAT into present value factor. So multiply 16,000 into 0.718, you will get 11,488. 18,000 into 0.609, you will get 10,962. 20,000 into 0.516, 10,320. 25,000 into 0.437 is 10,925. Now add up all these values. Your value is 55,553. Now if you remember the NPV, so your cash inflows, present value of cash inflows minus cash outflows, right? So your present value of cash inflows is this. Now cash outflow is your investment. How much was your investment? 56,125. Subtract this, you will get 572. Is it a positive value or negative value? It is negative value, right? So negative NPV. We don't satisfy with this answer. As we discussed earlier, we need the another NPV with positive value so that we can calculate IRR. Now, let us decrease this value. Try to understand. Let us decrease this value, decrease this discount factor so that we are going to get positive NPV. We are going to get positive NPV. Remember, decrease. Highest value will give you negative value, lowest value give you positive value. Now, we are decreasing to 17%. Let us check NPV. What is your NPV? 0.853. Luckily, by reducing just 1%, we are able to get it. If at 17 also, if you get negative NPV, then we have to assume either 15% or 12% or 10%, whatever the percentage you can assume, but that should give your positive NPV. Till that, we have to continue this process. That's the reason this method is called as trial and error basis. Clear? Now, we got 18%. The rate is minus 572. 17% at 853. Right? These are NPVs and these are discount factors. Now, we are applying the formula by using these values, right? If you recollect the formulae, what were discussed earlier, out of them, we have to use one. See, this is the another formula what we were discussed. If it is an annuity, then better use this formula because we have PB. Here we have present values, no? Here we have present values, no? So that whenever you have unequal cash events, cash flows, uneven cash inflows, better use this formula, right? So what is the formula? IRR is equal to R minus present value of cash outflow. This is same for every every interest rate. But if you come for PVCFAT, that is, if you take R as a lowest rate, then PVCFAT, that is NPV, whatever the present value you get it at R will be your PVCFAT. If you consider R as highest factor, then your PVCFAT will be the present value at highest factor, right? Same as the previous formula. Now, here we have delta PV, that is change in PV values, right? Same as the previous. So, you are differentiating, you are seeing the difference of PVCFAT at lower rate, also PVCFAT at higher rate. So, subtracting these two, that is what the change in present value. Now, here we have an additional value, that is delta R. Delta R is difference between the discount rates. Discount rates. For example, in the earlier problem, we took 16 and 18. Sorry, 16 and 17, right? So your delta R will be 1. If you take 16 and 18, then your delta R will be 2. If it is 12 and 20, then your delta R will be 8. Okay. Now, let us get into the process. Yes. So, this is a formula, no? Then R, we are considering 18%, right? Highest value. At H, we have 55,553 at 18%. Let me show you the previous slide. Is it 55,553 at 18%, right? So this is your PVCFAT. Okay. Now the change in PV, how you calculate it? 56,978 minus 55,553, right? So 8 minus 3, 5, 7 minus 5, 2, 9 minus 5, 4, 6 minus 5, 1. 1425 is a denominator. Now let us see in the formula. Okay, right? So this is what I explained in the previous. So this is at 17% PV and this is 18% PV, right? The difference of this. This you know, present value of cash inflow, outflow, that is investment. Now, the degrees you have taken 18% and 17%, right? Your answer is 17.6. Same, if you use 17% instead of 18, then here this will be same, but this is going to be changed as 56,978, that is present value at 17%. Denominator is, it is same, denominator is same, okay, and delta R also same. Clear? Now let us see the solution. 70, 56,125 same, 56,978, 17%, denominator is same, and delta R also same. This is also given you the same, that is 17.6. Okay, IRR for project A. Same way you are applying IRR for project B. Let us see what this IRR is. Right? Now, this problem has not given any cutoff rate. So, we need to compare IRR of project A with IRR of project B. Then, if it is greater than, accept this. If it is less than, accept this. If equal to, then discretion of the investor. Okay. Now, let us calculate IRR of B. So, directly we have taken 21%. Any person, there is no compulsion that certain person to be taken. So, tentatively, let us assume 21%. Okay. So, generally, you can start with 12%, 15%, or 18%. Depending on the percentage, depending on the value negative, then if value gets negative here, increase the interest rate. If you get positive value here, decrease, sorry, if you get negative value here, decrease the value. If you get positive value here, then increase the rate of interest rate, then calculate it, or discount it. Increase the discount rate and calculate it. Now, project to be cash inflows at PV factor 21%. These are the values. I have already shown you how to collect it. Then multiply 22,000 with 0.826, will get this value. Same way, multiplying the second year 20,000 with 0.68. Like this, we are calculating for all the 5 years. So this is your total PV, right? PV, CFAT at rate. We don't know whether it is a higher rate or lower rate, right? So you're subtracting your initial investment, then you got negative NPV. Because you got negative NPV, we need to reduce the discount rate so that you may get positive. So let us decrease the value to 20%. Calculated, here it is giving 1761, right? So your IRR is going to be lie between 20% and 21%. Right? So by seeing itself, this itself, you can say IRR of B is higher than IRR of A, because IRR of B is lying between 20 and 21, whereas A was 17, right? 17 point something. So of course, obviously we are going to select at IRR BB, but let us see what is IRR of B. Substitute in the formula, taking R as 20%. Substitute the values. You know that 56125 is common. This is the present value of cash inflow at present value of cash flow after tax at 20, right? And this is highest interest rate, the lowest interest rate, and highest interest. This is at 20%, and this is at 21%, right? Substituting in the formula, 21 minus 20, you got the value as 20. If you take R as 21%, then what is the answer? Same, you are going to get 20 point. So what is your conclusion? Conclusion is IRR of B is greater than IRR of A. That is 20.9 is greater than 17.8.